Hello, everyone. I'd like to welcome everyone to our second Greening the Landscape conversation of 2023. My name is Ryan Plummer. I'm professor and director of the Environmental Sustainability Research Center at Brock University, part of the Greening the Landscape Research Consortium, and I'm going to be moderating our conversation today. I'm just blown away by the response we've been getting to these conversations. I've got a counter going on part of my monitor here. At last count, we're cruising well past the 250 mark of audience members today, and I understand we have over 700 people pre-registered for our session. So I just want to say welcome to all of you. And given this positive momentum of the consortium and overwhelming response for our conversation today, I'd like to invite Dr. Darby McGrath, Vice President of Research and Development at Vineland Research and Innovation Center, as well as someone that I feel privileged to call a close colleague and personal friend, to say a few words on behalf of Vineland and open our event. Darby, please go ahead and kick us off.
Thanks, Ryan. It's wonderful to be joining everyone here today. As Ryan mentioned, I'm the Vice President of Research and Development at the Vineland Research and Innovation Center. And it really is my pleasure to be welcoming all of you to another session of the Greening the Landscape Research Consortium Conversation Series, our second of the year, in fact. Having the chance to say hello is near and dear to my heart because I'm proud to say that I was part of the consortium as it sort of launched, and I had the pleasure of developing the consortium and the conversation series as part of our knowledge mobilization toolkit. So this this initiative is a great example of what the Vineland Research and Innovation Center is created to do. So for those of you that don't know about us, I'd like to take this chance to introduce you to Vineland. We don't like to be the best kept secret, so it's a chance for me to talk a little bit about who we are and frankly where we are. So we're an independent, not-for-profit, results-oriented organization located in Vineland, Ontario. And our whole focus is really on horticulture, science, and innovation. We deliver innovative products, solutions, and services through an integrated and collaborative cross-country network to advance Canada's research and commercialization agenda. And our mission is to improve the economic viability, sustainability, and competitiveness of horticulture in Canada. So I said this before, and I'll say it again, urban forestry is often the forgotten child in horticulture. We don't always think of urban forestry as being part of horticulture, but it certainly is. And part of our job at Vineland is to ensure that we're delivering evidence-based processes, practices, and products to the industry when and how they need it. As part of this, we've really focused on urban forestry over the last few years because it's a sort of a space that falls between jurisdictions at the policy level and frankly with respect to the way that we handle it in our landscapes. So we've spent a lot of time working on developing toolkits and all sorts of innovative solutions to be able to push those out to people when and how they need them. So our research and innovation focus is really guided by our innovation strategy, and topical for the conversation series today is our goal to improve the connectivity of products and processes across supply and value chains. So a key gap that's often a barrier to the adoption of new technologies is this ineffective or inadequate mobilization of knowledge. And I think the conversation series is a really important way for the Greening the Landscape Research Consortium to actually be able to get those solutions to people. I'm really excited about the panelists we have here today. It's going to be an excellent conversation. I encourage you to reach out in the chat, talk to the folks that you have here. It's it's a privilege to be sitting on this introductory panel with all of them. And I think that the number of people that we have in the webinar that are rolling in, as Ryan said, it really demonstrates the demand for this type of knowledge mobilization and knowledge sharing events. So thank you for joining us. Come and see us at Vineland one day and enjoy the conversation.
Thank you so much, Darby, for sharing your insights, for your continuous overwhelming support for the Greening Landscape Research Consortium, and for an open invitation for all of you to come and visit Darby, Jason, and the entire team at Vineland. I look forward, and I know Darby looks forward to hosting you all. Before we get on to introducing our esteemed panel today, as Darby mentioned, just couldn't be more excited about that, but there's a few things I need to say as our moderator. We're very pleased again to be collaborating with ISAO Ontario on the conversation today. If you are an ISAO member looking to collect CEUs for this session, Please remain in the webinar for the full duration of the event so that our event metrics show that you attend the entire session. The session will automatically end and your window will close at the end of the event. These conversations provide an opportunity for mobilizing knowledge, as Darby talked about, by fostering dialogue among individuals with expertise on a particular topic, as well as engaging with all of you, our audience. That's what makes them so special. The title of our conversation today is Between a Rock and a Hard Place, Identifying Effective Soil Volume for Urban Sites. In the urban environment, trees are often planted literally between a rock, concrete, and a hard place. Usually it's more concrete, or at a minimum, heavily compacted soil. And through working with Darby and Rhoda and the entire team at Vineland, I've learned more about soil than I even thought was possible. When you're growing a tree in such a stressful environment, surrounded on all sides by hard-packed surfaces and concrete barriers, having someone who has thought about your soil volume and quality needs can be the difference between a long, healthy life or sudden death. Said another way, urban infrastructure barriers and the heavily compacted soil are equally unpleasant things to a tree. So, without further ado, today we're joined by three panelists to address how to best identify soil volume in this type of very challenging environment. And it's really paramount to survivorship of urban trees in dense urban cores in particular. Our first panelist is Dr. Susan Day. Susan, give us a big wave. Susan is a professor of urban forestry in the Department of Forest Resources Management at the University of British Columbia in Vancouver, Canada. Susan's research focuses on managing the below-ground systems to enhance urban tree growth and longevity in the context of environmental challenges, such as land development and stormwater mitigation. In particular, her research has included studies on the impacts of soil volume, engineered and manufactured soils, soil compaction, and soil rehabilitation. You can tell she's the absolute perfect panelist for her today. She's helped shape the Sustainability Cities initiatives, crediting systems for soils, and has published more than 150 articles and book chapters on urban forests and urban soils. She is a 2017 recipient of the L.C. Chadwick Award for Arboriculture Research. Susan holds a BA from Yale University, an MS from Master of Science from Cornell University, and a PhD from Virginia Tech. Susan, a warm welcome to you. Thanks so much for joining our panel today. Our second panelist is Dr. Jenny Hill. Jenny, give us a big shout out. Welcome. Jenny has recently assumed the position of Associate Dean at Humber College. Earlier this year, she concluded a term as an Assistant Dean at the University of Toronto, where she also taught landscape hydrology and hydraulics. Her previous roles include 3 years as a research scientist in the STEP team at Toronto Regional Conservation Authority, revising their online guide for planning and design of low-impact development. Jenny has contributed as an expert in green infrastructure to the Savings by Design program for Sustainable Buildings Canada since 2015. Her consulting and research work encompasses the integration of functional vegetation to the urban realm at both landscape and building scales. She is licensed to practice both landscape architecture and stormwater engineering. Her degrees include a PhD in water resources engineering, an MA in landscape architecture, an MSc in forensic science, and BSc in analytical chemistry. So essentially, I don't know what further degrees Jenny could possibly amass or positions to be better suited to join us today. Welcome, Jenny. Last but certainly not least, we have Vineland's very own Jason Henry. Give us a big wave, Jason. Jason is a lab supervisor for environmental horticulture in the Plant Response and Environmental Program at Vineland Research and Innovation Center. He obtained a BSc in Environmental Science at Trent University, where he also conducted his MSc research investigating the influence of nitrogen deposition on Irish grasslands. In the last decade with Vineland, Jason has worked throughout the urban forest industry, conducting research and providing technical guidance to support the establishment and survival of trees and shrubs in the urban landscape. Apparently, we found out right after this call, Jason has to run to give a presentation at a conference, so he will be, of course, obeying the speed limits as he quickly makes his way down the road to Niagara Falls. His current research focuses on improving soil quality and health before planting, and has recently launched Vineland's Soil and Substrate Health Laboratory. Jason resides in Niagara Falls with his young family and is on the board for Landcare Niagara. So with that esteemed set of panelists in place, I'd like to kick us off with our first question. And this question I'm going to pose to each of our panelists. So I want to hopefully get your unique perspectives and eminent qualifications to reflect on this question. What role does soil volume play in affecting urban tree survival, establishment, and growth? So I love this question because really it's one question, but really I want you to speak to three different things, right? So the role of soil volume in affecting urban tree survival, establishment, and growth. Jason, since you had to wait for your introduction as a panelist last, I'm going to kick this off with you. Start us off.
Thank you very much, Ryan Plummer. This is such an amazing opportunity to speak about a great passion of mine, really soil and soil volume. I love exploring, digging holes, and really getting to the root of the issue for why trees fail in the urban environment. When we think of trees and the urban forest in general, we typically focus just on the above ground portion. We have our canopy cover targets, we look at growth, how tall those trees are going to get, the vigor. But really, the amazing part that I thoroughly enjoy is that below ground part. It's an amazing and complex root system network. In environments with unlimited rooting volume, roots can extend 2 to 3 times the size of the canopy. This is an enormous, amazing network of roots that really support that above ground portion. When we go into the urban environment, soil volume really dictates how much those root systems can expand and really take advantage of that new environment. Unfortunately, in urban landscapes, we as people take up a lot of space to build our infrastructure, our roads, buildings, putting tons of pipes and wires underground. And this really cuts into how much space trees can get, or tree root systems can really access and take advantage of. Root systems and the space they use really provide the nutrients, nutrients, water, and oxygen that the tree needs, but also the structural support. Limited space reduces all those opportunities, and which ultimately affects our above ground tree survival, establishment, and growth. Limited space really dictates those three categories of growth above ground. And because I work in the soils world, we are horrible at jokes, but the tongue-in-cheek joke that I want to say is for the soil research. In urban forestry, we tend to spend a lot of money on the above ground portion, installing the tree, picking the species, and then having that all placed in. But we really put a limited investment in on the soil and the soil quality. And so this is how we end off. How I like to end off with this question is with a joke.
Thanks so much, Jason. Susan, I saw you nodded a lot when you were listening to Jason, and I'm curious, tell me how you would answer the same question about the role soil volume plays in affecting, survival, establishment, and growth.
I mean, I think all those things that Jason said are, right on the money. I mean, essentially, the below ground system of the tree has to access water, nutrients, and has to have space for anchorage, right? So the soil volume is critical. But I also want to sort of think about this in maybe almost a historical and future looking way. So in the last 50 years or so, we've have more densification in cities, right? So we have more sort of intersections between pavement and trees. We also have much more aggressive construction techniques and engineering. So if you look at old neighborhoods, maybe built in the 1920s or something, the trees appear to have limited soil volume, but they're much bigger, right? So we really have two systems underground. We have this whole engineered system, and then we have this soil volume, ecological system underground. And so in getting to your question, I think the thing that's really most compelling to me right now at this point in time is the resilience aspect, the survival, because we're having periods like in British Columbia, we're having longer dry periods and more intense rainfall. And if you just think about soil volume and you don't think about the whole system, I really think when you're thinking about soil volume, which is critical, you have to think bigger too, then you miss the impact limited soil volume and the surrounding soils can have on this resilience. So when it's drier, if trees are only accessing the soil you designed for them, then they're going to suffer from drought and you're going to have death. And we're seeing that with like Western red cedar in British Columbia. But then conversely, like when it rains a lot, you could have, say, compacted soil underneath your design volume, and you can get water backing up in the system. Then you could make trees could be more disposed to diseases like verticillium wilt or, other things that come along with, too much water, right? So I think, Jenny's probably going to talk about the hydrology aspects of this, but I think it's critical to know that one, you have to have a lot of volume, but then there's also this whole system aspect of it that you have to think about each individual situation. You can't just say, I'm going to have this much volume and everything's going to be great. You have to think about even broader than that. I hope I didn't get too far off your question, but that's what I was thinking about when Jason was talking about all those things.
Yeah, Susan, not off the question at all. Two, I think things stick out for me. Number one, these conversations, we purposely find experts across Canada and throughout the world to bring in for their different perspectives, and the way that you're able to share your experiences currently, in Western Canada is so valuable because everyone's going to have a slightly different perspective, but thinking through that systems way, and as a scholar of resilience and social ecological systems myself, everything you said just landed and really resonated, because it is those interconnection of factors that's so rich. And I think you're right. I think Jenny probably is I see her like moving in her chair, wanting to answer this question desperately, because she's going to speak, I know, about the hydrological aspects of this. So Jenny, why don't we give you an opportunity to answer this same question, and feel free to pick up on something that Susan and Jason have said, or go a totally different direction with it. But same question about, what's the role of soil volume in affecting urban tree survival, establishment, and growth?
Well, thank you, Ryan. Yes, I was furiously making notes whilst I was listening to Jason and Susan talk to this. I was going to actually start with a very sort of academic angle and literally answer your question, which was about the soil volume and survivability. And I was going to make reference to where some of the original research had come from and the academics of it. And when I was thinking about this, I found that the Lindsay and Bassett model from early 1990s had actually found that the soil requirement was correlated with a whole bunch of factors, including the storm inter-event time, the maximum evapotranspiration, leaf area index, and crown volume. And then over time, researchers had actually flipped that model and said, well, if we provide a certain soil volume, we can therefore expect to maximize leaf area index and crown volume. And this all sounds great, and it certainly would work to a degree, but there will come, in the natural forest, there is a limit to which any individual tree can ever maximize these factors. And so a lot of research has relied on these models to help us come up with these soil volumes. But As Susan was just referring to, we work in a very complex and difficult environment downtown where lots of other factors are coming into play, such as the soil quality, whether that be chemical, biological, or physical, including, compaction and the even the blend that's put into place. And then, yes, naturally, I want to turn to talking briefly about water volume. So over here in Ontario, we have very different rainfall characteristics. At the moment, although climate is changing, we tend to see inter-event times of 2 to 3 dry days on average. But of course, that varies hugely from season to season. That is very different from the BC climate, where you're getting more regular rainfall. And so we're much more reliant on irrigation. And from my observations in urban forests, I see an awful lot of empty gator bags. And, a zipped on empty gator bag is really not doing a whole lot to help that tree get established. The other factor that we have over here is the deep winter. And those who are listening in on the audience and are in this same climate as me, they will know already that chloride and also the sodium tends to be a bit more mobile. Other way. Chloride is more mobile, whereas the sodium tends to stick around. But winter salting is a big issue also for the urban trees. And so providing that extra soil volume helps give the trees a little bit of resilience against both poor water quality, including winter salting, and also dry spells. I wanted to touch also, if I may, a little bit on the difference in regulation between municipalities out on the West Coast and some of those more local to us. And this also relates to stormwater volume. And Jason had spoken a little bit about alternative tree support systems, including structural soil and cells. What we see is municipal regulation varies in so much as the credit that developers can get for installing those systems varies a lot from place to place. I know that out west, there are some municipalities where the developers at a site scale are responsible for installing shade trees in the right-of-way. And then they can use that tree system to capture some of the rainwater that they have falling on their building lot. In some municipalities locally, however, this permission is not granted. So the incentive to provide that soil volume is lost because the stormwater connection isn't there from a regulatory standpoint. The trees are seen therefore as less important. They're more just about urban realm dressing. They're like the finishing touch, but they're not being given the opportunity to really provide that infrastructural benefit. And that is a matter of regulation and the regulatory drivers at play here.
Benny, thank you so much. Fascinating how each of your perspectives on a single question really complement each other. And I really enjoyed the specificity and thinking not only about the different geographical areas that we work, but also the policy aspect that municipalities can potentially have around setting, with developers and so on, and the implications on this, because oftentimes we might not think of those. But I want to pick up, Jenny, on one thing in particular you said here as I move into the second question that I get to pose to the three of you. That is around what research tells us and how some of these, rules of thumb that we have about, if we're thinking about, where some of these could be myths maybe come from. I don't know, but, I'm thinking specifically, many of us at this conversation today, we're aware that there's this established rule of thumb for recommended minimum soil volume of 30 cubic meters per tree. And before I unpack this a bit, let me ask you, Jason, can you tell us where the heck this comes from and explain to all of us where this rule of thumb comes from?
So this is a big question, and I love this question because I really like rule of thumbs to help guide a lot of our municipal partners on planting established trees in such difficult planting conditions like the urban landscape. The rule of thumb of 30 cubic meters is really an interesting and unique perspective on how much space a tree root system in the urban environment needs. Like I said, in nature, trees are allowed to grow to their exact needs. There are no limitations on that. But infrastructure in our landscape really needs to take and cut into those space requirements that tree root systems need to go. And so really setting a threshold in place is a nice way to really focus on a target that we can use in a built landscape. When I'm thinking about this, especially this plays into kind of new residential developments where everything is so carefully planned, calculated, and mapped out, sometimes to the millimeter, where we know exactly where things are going. And so this number and these types of rule of thumbs allow tree experts, but also non-tree experts to help plan out space for where a tree can go. This rule of thumb becomes very, very difficult and very broad when it comes into already pre-established built infrastructures. And so there are key tools that we can use. But this rule of thumb is a really unique way to kind of help plan out. So that's really the why. And the question was really on the where. And so the where is it really came out of the academic research, but also industry experts. Many different areas have been focusing on this question from, it's really even started from the 1930s and really carried forward to the early 90s, and it's continuing to kind of evolve. And you have a lot of great people here with Susan Day and Jenny Hill that have really focused on this on a municipal level. So to answer the question, in the research world, it's what Jenny Hill was actually mentioning with kind of these small trials and also basing it on model data when this originally started out calculating these, how much volume of soil a tree needs. And one of the ways that was done is really looking at what a tree needs on a daily basis. So how much water it's going to be absorbing and utilizing and evapotranspirating, and then really how much that soil can hold and for available water. So essentially you have your water pool in your soil, and then you have your absorber with the tree. And then we calculate out exactly how long it takes for that tree to take up all the water. And then we look at the recharge rate. When that precipitation comes in, fills up those kind of pores and macro pores to make that water all available again. This was kind of one simple way and kind of a very unique way to really calculate out soil volume in general. And it's based on the hydrological cycle. And one of the biggest reasons why that is because water is generally the limiting factor for trees to grow. It's one of the basic starting points, and this is kind of where we pushed a lot of the research in the early 90s and all the way to now. Other research is focused on air spading out the trees and actually looking at where root systems grow and actually how they influence the above ground growth. So there's a lot of research that has come to these numbers. It's going to vary region to region, but a rule of thumb is just in place to kind of help guide us for the future. And so I know it's a bit different probably out in BC where there's a bit more rain. In Ontario, we went weeks, unfortunately, without rain this summer. And so this all influences our hydrological cycle. So it will depend on where you are in the world, but a rule of thumb is a good place to start and to start these conversations.
Thank you so much, Jason. I mean, I appreciate that, your last statement there where you were indicating that, a rule of thumb is kind of like a guideline. I myself usually interpret rules more as guidelines. Just, I don't know what that says about my personality, but I think, it's a really important statement here because, listening to Susan and Jenny earlier, I mean, they touched on the fact that, this is a really complicated piece of understanding that we need to do. And so I'd like to ask Jenny and then Susan in turn about, what are other key factors a practitioner should consider in order to identify and define the appropriate soil volume for trees in their urban planning projects, as opposed to just adhering to, this specific number?
Yeah, I can speak to that. Thank you, Ryan. What I've observed whilst I've been consulting and helping out with various development proposals, both as a private consultant and working in municipal governance, is that arborists are not necessarily being consulted during development proposals, apart from they're always mandated to be brought in for the remove and injure list. And that must be rather dispiriting as an arborist, being sort of not consulted thoroughly to help with replacements and reinvigoration of the urban forest. So I think there's an education piece here for other design experts to know that the arborists have this wealth of experience and are wanting to share this. So that would be architects, and even landscape architects sometimes lack the depth of knowledge to understand about species selection for the particular locations. One thing that they may not be aware of, that I'm sure many of our audience are, is that when planning in the urban realm in very tight spaces, the trees, most species are going to want very much more area in the plan section, in the XY realm. They want to be able to spread their roots out beyond the drip line. They're not necessarily needing a great deal of depth. So, I mean, it will vary. Some trees are much more deeply rooted than others, but there are many species that can be selected that are going to have preferences one way or the other. And when rooting volume is something that we're absolutely juggling down to like the nearest, foot either way, then that is something that would be really valuable for people to have more knowledge about and to draw upon. Right, Jason just spoke about there being rules of thumb for different sizes of trees. And one of the initiatives that I've come across recently was a town of Caledon here in Ontario have drawn inspiration from a number of other municipalities, including, I believe, City of Portland. And they have a draft proposal, which is currently public online. So I know that I can tell you now about this proposal they have, which is going to be to provide a nuanced approach for urban street tree selection. So unlike some municipalities who have gone with, you must have 30 cubic meters of volume. And then what we see in practice is that when the development team cannot provide that, the trees are simply axed. Okay, we cannot provide 30 cubic meters, therefore no tree. What they're doing in Caledon is they're actually providing a three-tiered sort of regulation, where if you have the large volume available, you must plant a large shade tree. If you can accommodate a medium-sized tree, then they have a preferred list given that soil volume. And if you don't have that soil volume, then they have a list of preferred ornamentals and shrubs. So then we're not having this all or nothing approach. I think that again, I'm speaking to the sort of the drivers from regulatory standpoint, this black and white sort of question about trees being in or out is a pretty terrible way to try to improve our urban forest density. And I would love to see more grey area regulation where we have this accommodation of limited soil volumes, therefore a diminutive tree. And then we could just overall increase our canopies.
Thank you so much, Jenny, for such an inclusive response to the question. I just think it's illuminating to hear about some of those different considerations. And I love, the fact to say, let's increase the gray area and find a way to get more trees and more healthier trees by extension. Susan, I want to go to you next and ask you the same question that I just asked Jenny. I'd love to hear your perspective on what are these other factors that practitioners can consider, should consider appropriate to soil volume, as opposed to just this one number.
Thanks, Ron. I think this is such an important point. And as Jason said, having a rule of thumb, having these numbers, that's really useful. I mean, it's transformed the way people are designing the below ground streetscape, right? So it facilitates communication, but the pitfall of this is exactly what Jenny was saying, is that it's not black and white. Like, so when we say, oh, you need 30 cubic meters for a big tree, if you're thinking about a system from an engineering point of view, you think, okay, I have 30 meters, I'm done. My tree should be great. Everything should be wonderful. But that's not really true. If you think about, if you do like a back of the envelope calculation using like forestry stocking charts, which is essentially what's the carrying capacity of an acre or a hectare of land for forest biomass. if you do the calculation for how much soil is needed for a certain amount of biomass, it's actually way more than 30 meters, right? So 30 meters is kind of what we can reasonably get in a city. It's possible. And we're really counting on the soil beyond that 30 meters to help anchor and supply the trees. So I'm sure you've seen this, like if you have trees that are planted on slabs, so they're over like on structure, so that maybe there's a parkade or a parking garage below ground, and so the soil volume is there, but it's actually in a box. The root can't get beyond the soil volume because, say, there's concrete. Those trees are not doing well. So in British Columbia, for example, it rains a lot, but we also have a really long dry season where it may not rain for a month easily, and so you really see that suffering when you don't have the roots going into these nooks and crannies, like underneath sidewalks and pavements, or accessing little bits of lawn that are nearby, or having a few deep roots that are going into those reserves of water that are way below ground, right? So I think this question of the number, you have to really take it with a grain of salt. And I think what Jenny pointed out about the regulatory environment and how people can take that number and kind of misuse it, right? And so they sort of say, oh, well, we don't have our 30 cubic meters, therefore we shouldn't plant anything. There's lots of ways to support trees and different strategies, and you can have a soil management program that tries to protect the deeper layers of soil. You could have different standards if you're planting like on structure. You could have breakout zones where roots can get under pavement into adjacent areas. There's all different kinds of ways to increase the roots' access to the below ground environment. And I think you have to explore all of them. And that's why we need arborists and landscape architects and so forth with expertise in this area that can really look at each situation and make some decisions and judgments. Like I see in the Q&A, there's lots of interesting questions about these things. Like there was a question about salt spray. And I mean, these things are individual to each site. And so we really don't want to be applying policies in this just kind of black and white, one size fits all way, because we know it's not true. Tree species are different, climate's different, soil's different, the infrastructure is different. Even the way like the pavement's constructed is going to be different depending on whether it's a highway, a residential area, a commercial district, right? So I think there's lots of ways to be creative and create more below ground space so we can have real trees. So that's my 2 cents.
Well, Susan, I love your 2 cents and the thought of having real trees. I mean, if we were going to put a logo on a t-shirt, maybe for the conversation day, it's like, rock hard place for real trees or something like that. There's an idea there. Yeah, perfect. And it's also the perfect response, Susan, just to lead us into our final question before we open things up to the audience. As you said, Susan, I mean, the audience is posing lots of great questions, and I'll get to some of those in a minute. Before I do, and while the audience is contributing those questions, I'm going to actually go back to you, Jason, and I'm going to challenge you because I know how passionate you are about your last answer, and I'm going to challenge it and say, while we're paying all this attention to soil volume, to me at least, soil quality is equally an important factor in affecting tree survival and growth, as Susan just articulated, right? Why I thought Susan's answer was so great. What does the current research tell us about the relationship between soil quantity and quality? Easy last question here, Jason.
Well, thank you so much. And I love both the answers just before. And I really like the misuse of soil volume. That's a brilliant and segue into kind of this question here. Soil health and quality really needs to play hand in hand with the volume side of things. And the reason why I'm really passionate about soil health and really functioning soil is kind of one of the first research projects that we did here at Vineland which was looking at highway soil and the quality of highway soil. So these were unlimited soil volumes. The trees going onto this site, soil volume was not a restricting value. These were on cloverleaf highways, and we're planting just a few trees, and the roots could expand any which way they want. And 3 years later, I could still actually pull the tree out of the planting hole. And I'm not that strong, so it's really shows you where the quality side needs to factor in. And the site that we planted on was a right-of-way highway site, and the soil was actually designed by our specifications to be the same quality and density enough to hold up a roadway. And we're planting trees in this, so there's usable soil volume and then really unusable soil volume. And soil health and quality really factor into the usable side. The trees that we were growing had 0 usable volume, and you could see it just in the root systems where they could not physically penetrate through that soil. It was just so compacted, and the overall quality just wasn't there. And so when we focus on soil health, what I love to focus on is really the chemical, the physical, but also the big push now is the biological side. If the microbes and there's nothing living in that soil that's really functioning, designing that soil and really keeping that soil alive, because soil is a living ecosystem, how can we actually expect our trees to survive too? They're living organisms too. And so when we're really focusing on soil health and quality, we're focusing on all those characteristics to make sure that the soil is living so that we can really support that tree.
Yeah. Thanks, Jason, for really speaking to the intricacies of this relationship between, soil health, volume, and some of the challenges, many challenges that are faced in these urban environments. Susan, can I ask you about your experience and what cutting edge research is telling us about this relationship between soil quantity and quality?
Well, there's 2 things I think that would be worth talking about. And I know there's a lot of questions in the chat about different types of soil. And of course, in Canada, we have the Canadian Landscape Standard, which has a suite of soil specs in it. And so there are issues concerning those soils that we specify for the soil volume. So that's one aspect. But just sort of more fundamentally, a more fundamental way of thinking about this in just quality versus quantity is of course you have the quality of the soil matters, right? That you have in your design volume. But we did a study, I don't know, about 15 years ago, and we looked at different soil volumes, and we were looking at one aspect of quality, which was compaction level. And so when you got down to the compaction, so the more compacted the soil, the smaller the trees, until you got down to a certain volume. And once you got to those really too small volumes, it didn't matter whether the soil was more compacted or not, because the volume was the limiting factor, not the soil quality, right? So there's a point when soil quality is going to matter more or less, depending on the volume. But another aspect of this quality question is not just the quality of the soil in the design volume, as we were talking about. It's, what's below that, what's adjacent to that, like what's under the sidewalk, what's under the pavement, and so those soils matter as well. And I think another issue that comes up with soil quality is also kind of how we manage soil. So if you're working in a heavily engineered space, and there's a lot of engineering practices that are coming into play, it also depends on sort of like how you look at the soil, so even like the way we measure soil compaction, like Proctor density, for example, that would be a way that you measure the sort of the compactability of the soil as a percentage of the maximum compactability you can have for a given soil, right? That's really focused on holding up a structure. You want to make sure your soil's stable, so, well, the road won't sag or your building won't sink or something like that. And when you use those kinds of measurements on soil that are for trees, it can create weird dynamics, where, so for example, if I say, oh, I want this to be compacted to 80% Proctor density, that's sort of a bottom threshold because it's something it's designed for stability. Whereas with trees, you want it to be as uncompacted as possible, right? So even like the kinds of measurement tools that we use have a kind of bias built into them. And it's important to think about these things because this can really affect the quality of the soil we put into our spaces. And I think there's lots of interesting questions about these soils that we create, whether they're specs through the Canadian Landscape Standard or other standards, or they're structural soils or other kinds of engineered media. There's lots of questions how they behave. And so that's a big topic.
Sounds to me like a lifetime of research ahead of you, Susan. That's for sure. And I know someone that shares that passion is Jenny, and I'd love to get your perspective, Jenny, on this relationship between soil quantity and soil quality.
Oh, I wanted to join in and jump in as Susan was talking about the horrors of density and like the very tight urban space. I was going to share some horror stories about maintenance practices as well. Because amongst our community, we can talk about like planning and installation of trees. I already alluded briefly to like irrigation, which is usually the first couple of years. But the reality in many urban environments is that the maintenance then is down to the urban forestry team, who are going to come around periodically and look at these trees. But then there is often a connection gap or a disconnect between their jurisdiction and their realm of operations and that of all of the utility providers. And the utility providers will come around typically every 5 to 10 years on any given sidewalk. They're going to tear it up because the cable, the gas line, the water mains need some sort of inspection or maintenance. And that might be either an emergency response or it might be a planned operation. But these construction crews are not familiar with the needs of the trees, and the trees often slip down their priority list. And I have seen and heard of many examples of the trees planting mix being taken out a few years after the tree was installed, and then it's replaced with unshrinkable fill. And unshrinkable fill is basically concrete. So they will take out the mix. They're like, yep, we've done our repair to this like piece of infrastructure that's next to the tree. That's our priority. It has now been dealt with. We will put granular around the piece of infrastructure we care about. And now our main priority is to make sure the sidewalk is stabilized. And the way that they stabilize the sidewalk is they pour this unshrinkable fill or concrete in around the tree base to make sure that everything's nice and stable. So we have like some sort of education piece there to bring to general contractors so that they understand better about the needs of living infrastructure and that it has value to us all, and that it isn't that the cable has more value than the tree necessarily. However, so I just made that note because I was like, oh, the horrors of like compact environments. But what I really wanted to speak about with regard to tree planting media was I was going to speak to bioretention and soil stormwater systems. And indeed, I note that somebody's already raised this as a question. And one of the things, there's a couple of things that I wanted to say about that. So one was, it raises an interesting question when we come to talk about salinity and aridity of the environment again, about species selection. So in Ontario, we are not a coastal environment. It would not usually be appropriate to specify coastal species. But in the urban realm, where we are very disconnected from necessarily sort of naturalized areas, there may be an argument that some out of province species should be trialed in these unusual environments where we've got a lot of salinity, we've got a lot of unusual sort of climatic effects caused by the city around us. And so maybe in some contexts, when we're talking about planting bioretention and we're worried about salinity, it might be a good argument to not go with something that is very local and native, but perhaps something that is continentally native as a way of exploring that. And I've spoken to various landscape architects that have discuss this issue. I know that it is contentious about the idea of bringing in ornamentals for that kind of thing. I've also heard suggestions about designing stormwater systems so that the trees are actually partitioned and separated out from the bioretention system at large. Usually, we're fighting for soil space as it is. I think that trying to get the space on the ground to have both excellent tree planting and excellent bioretention is going to be very difficult, if not impossible, in most circumstances. So I think we do need to continue to explore to find ways to integrate trees into these kinds of stormwater systems. The examples raised by the audience member were quite well established systems in Mississauga. Because they were established systems, they're also quite early systems. And early design development of bioretention was done largely by engineering folk, and their priorities were about drainage. As such, the bioretention media specifications were very high on sand, they were very low on fines, and they had very little regard for organic matter content. So effectively, the trees were being asked to survive in what was a sand filter. And from a stormwater point of view, they did very well. They didn't overflow or flood too much. And so they achieved their drainage goals. What we have been working towards, and particularly when I was with the STEP group doing the STEP LID guide, is we tried to speak to a lot of people, both experts in the field and also practitioners who were sort of in peripheral professions, about raising awareness about organic matter and the importance of organic matter in this kind of high draining media. And what we found was that people were using the terminology very differently. If you send off a soil sample to the laboratory and they tell you about organic matter, what they've done is burn it all out and then tell you what combusted. However, if you go to perhaps a soils yard and you ask about organic matter, what they mean is how much compost went into the mix. And if you burn up compost, it's only about 50% organic matter. So you can end up with huge discrepancies between people's understanding, depending on what their background is and what their discipline is. Long story short, although I've already done the long story, we need to move towards, and I think we are seeing great progress in moving towards having more organic matter. Even if it's in chunky components, the water and the nutrients can still get in and out of the individual particles, but seeing more of that in the blends that are being used for bioretention. So they will still drain very well, but they will have a better resilience to some of the other urban stressors. I'm going to just stop right there because otherwise I will talk for another half hour on the subject of bioretention media, Ryan.
Jenny, when I moderate sessions at conferences, my go-to move as a moderator is I just physically get up and start moving towards a person on the stage. And my whole strategy with that is, by the time you get within about 2 feet, the audience is just erupting in laughter because they actually think you're going to just run into the person, and it naturally stops it. But it's hard for me to do that. So I appreciate you sticking your time. Thank you so much. Wonderful answers, to all of our panelists, and thanks for drawing attention to the amount of research we need to do to navigate these very complex challenges. I've been monitoring, and the team here has been monitoring the questions coming in. I want to say to the audience, and our panelists, there's a lot of desire to have resources shared based on many of the things that you've spoken about, whether that's a particular, like the city of Portland or Caledon, for example, or experiences in Western Canada. And I want to just ensure the audience that will work with our panelists to share all the resources that we possibly can with those that are on our call today. I want to take time just to ask a couple of questions, and I'm going to ask our panelists to keep their answers concise, and I'll ask one panelist to speak to each of these, just so we can try to get to a couple questions. So the first question from Mary: do you recommend the use of structural soils and/or silvicelles to provide the soil volume? Have you used them in your area, and is it successful? I'll allow the panelists to self-select who wants to tackle this one, and we're going to do speed answers. You have one minute to answer this question.
I'm going to go with yes, I have seen them being used. As I in my first answer at the first question, Ryan, I said that there are regulatory drivers in their use, and we see them being used much more over in Vancouver than we do in some Ontario municipalities because of the connection to stormwater, and so the double benefit being recognized.
Jenny, I am 30 seconds. That was incredible. Thanks so much. Susan, I'm going to send this next question out to you. Ready? Okay. So David asks, can Susan speak to the comparative pros and cons? So Susan, you have 30 seconds each, and I am so apologetic to have this so succinct, of engineering soil systems, i.e. structural soils versus natural mineral soils.
Okay. Hi, David. Great question. So the pros of the engineered soil systems, and I include structural soils, but I also include our soil blends, like the ones that we specify, the mixes. The advantage is that you can make them and you know what their properties are going to be, and they can be readily available. The cons are they can be expensive. They do not necessarily change over time and develop the sort of biological life and the characteristics that a natural soil develops over time. And the final thing I'd like to say is that many engineered soils rely on large amounts of gravel or sand in order to have adequate drainage rather than soil aggregates. And that means that they are likely to be more droughty and hold fewer nutrients than a natural soil. That's my short answer.
I'm speechless at these short answers. They are so precise. Incredible, Susan. Jason, this one's going out to you. You ready? Okay. Laura asks, how is soil volume that is shared between neighboring urban forest trees best calculated? And I don't know the name of the second attendee, but this is a question coming up frequently. So Jason, you have 1 minute.
All right, I hope I understand this question. So trees planted to kind of undisturbed natural soils, I think is what the question's asking.
Your interpretation of the question, Jason, is as good as mine.
All right. It's very difficult because in natural settings, you have different trees and different vegetation actually absorbing that water. So how it contributes to soil volume, trees interact on a root level. They're constantly working together, working against each other, but really working in the soil to generate the resources it needs to gain and gather to really promote its above ground growth. And so it's gaining access to nutrients, water, and oxygen. And soil volume is one of the toughest ones to really answer because there are so many dynamic factors that really contribute to it. Whether the tree is getting irrigated, how healthy that soil is, and really what species it is, and really what climate are you in. And so unfortunately, it's very complicated to answer in 1 minute. But
well,
there are
complicated. You did complicated in 1 minute, Jason. 58
Perfect.
seconds. Perfect. Let me throw this final question out. And again, I appreciate your understanding, your sense of humor as panelists, and I apologize for the quick lightning round of questions to end this. But our last question comes from Tristan, and I want to give each of you, just a brief moment to speak to this. Has there been any documented follow-up research on success of root breakout zones in terms of actually providing usable access to additional rooting areas under sidewalks and any other hard structures? So a question for anyone who would like to answer it. Any documented follow-up research on this? Jenny, kick us off. Susan, Jason, you're on standby.
I'm afraid that I'm going to answer this with a slight tangent, which is my observation that there are many manufactured products now coming to market to help make sidewalks and surrounding hardscapes more resilient to root uplift and to accommodate root uplift. That tells me that it's definitely happening and that it's happening quite significantly, and that the market is responding by trying to make sure that the traditional grey engineers have a toolkit to help accommodate this kind of root breakout.
Thanks so much, Jenny. Susan, Jason, anything you want to add to that you're aware of?
Yeah, I'll add something. I think I'm not sure I've seen any recent research documenting this. However, I have students in my class every year go out and measure the design volume for trees and then look at the size of the trees, and these are trees that are kind of maxed out their volume, and look for patterns and anomalies. And invariably, they find there are many trees that are much bigger than you would expect them to be. And if they look around, they can usually find a reason why that is. And it's usually there's an adjacent planting area or something like that. So I think it's easy to go out and document instances of this making a significant difference in existing trees.
Thanks. Thank you so much, Susan. And unfortunately, we're going to have to leave it there today since we're just at time. And I'd like to close our conversation by expressing all of our collective appreciation. I hope our panelists feel good thoughts from all of our audience members, our sincere appreciation to our guest panelists who joined us today and generously shared your time and expertise. Susan, Jenny, and Jason, sincerely, thank you so much. Our appreciation also to ISAO for collaborating on our conversations today. And as a moderator, I also want to thank the entire Greening Landscape team behind the scenes that made today happen and possible. To all the ISAO members collecting CEUs for attending today's event, a friendly reminder that if you, one, provide your ISA number at the time of registration. Second, we're online for the full duration of the conversation. 1 CEU credit will be automatically provided directly by ISA Ontario. No additional action is required to collect your CEUs. If you did not register your ISA number, please feel free to contact the team at ISA Ontario at info@isaontario.com. Lastly, but certainly not least, I'd like to thank all of our members who make our conversations possible. A friendly reminder to share your thoughts and feedback on our 2023 conversation series by completing the post-attendee survey here on Zoom, which should appear on your screen when you exit the session. Thank you, everyone.
Thank you. Bye.
Thank you.
Thanks.
Bye-bye.